Hello everybody and welcome back if you're a regular, welcome if this is your very first time. So I'm going to be going through the 2014 Canadian Open Mathematics Challenge paper. So it's a wonderful math contest. It's got 12 questions on it, and you're encouraged to write this if you're sort of later high school, although I do believe just about anyone can write it. Don't quote me on that. But it's an excellent paper, gives you a chance to practice your written solution skills and things like that. It's made by the folks at the CMS, the Canadian Mathematical Society. They got a team of people who make up very nice questions there. And let's just take a look. So this is the exam paper, or the contest paper. Don't think of it as an exam. It's a contest paper. There we go. We've got our questions. And this is sort of what the booklet looks like. And this year's will be similar. So the papers are written in early November. This is the one from 2014. And let's just take a little look here. So we've got general instructions. I'm not going to read all of these things. Most of them are sort of basic test things, like don't open the booklet, that sort of a thing. One important thing to note, calculators are not allowed anytime you're doing a math contest. You should know what electronics are or are not allowed. Calculators are not for this one. Whereas other contests, some calculators are allowed, but maybe not programmable ones or graphing ones, that sort of a thing. Okay. Other things that are important enough to note right at the start, you have 2.5 hours to do the paper. As I said, there are 12 questions. Each are broken down there's 3 parts, each with 4 questions. And these are harder questions as we get further into the contest, and they are correspondingly worth more marks. And the Part C questions especially, you need to show all your work and justify everything. If you use the Pythagorean theorem, say, by the Pythagorean theorem, that sort of a thing. Okay? For all the questions, if you write down at least a little work, you can get part marks even if you don't get the right answer. Okay? So you can get a copy of this contest by clicking the first link in the description down below the video. And if you want to, print it out, read all the instructions. It's always a good idea to know what's in store for you if you're going to write a contest. So this is just this stuff here is just where you would fill in your name and all those sorts of things for bookkeeping. But here we go. Here's our very first question, A1. So we're just going to go one question at a time. So we'll do A1 in this video, A2 in the next, and so on all the way down to C4 in the last video. Okay. A1. In triangle ABC, there is a point D on side BC. So that AB is equal to AD is equal to DC. So I'm seeing a lot of isosceles triangles. Okay? There's 2 of those right there. Suppose that angle BAD is 80 degrees. Determine the size of angle ACB. ACB is down here. So we might call that X, angle X, or theta, if we're a little older or have done a lot more math on our own, but we just want to figure out X. So let's go to our little notepad here. So we're really just going to use our 2 isosceles triangles. So I've got 80 degrees here, I've got X degrees here. Now let's say over here this blue triangle is isosceles, and what's the nice thing about the isosceles triangles? Well, angles opposite the equal sides are themselves equal, so if we've got an X degrees down here, we've got an X degrees up here. Okay? What else is nice? Well, if you're familiar with some triangles, you know if we extend a side, we can get what's called sort of an external angle. And if I know the inside angles, call them maybe dot and check, they add up to the external angle, because we've got a full 180 degrees here, and the sum of the angles inside a triangle are 180 degrees. So what does that tell me? Well, I've got X and X here, so I've got 2X degrees here. Great. But then we have another, let's say green, isosceles triangle, and so angles opposite the equal sides are themselves equal, so we get a 2X degrees here. And now inside the green triangle, we should have a total of 180 degrees, but that's 80 degrees plus a 2x degrees plus a 2x degrees, 80 degrees plus 4x degrees. Subtract 80 degrees from both sides, you'll get 100 is 4x degrees. Divide by 4, and you will get 25 degrees is x degrees. So x is 25. Okay. And there we go. And so if you just want to, for the A through B parts, you could say that angle AB or ACB is 25 degrees and show no work. But if you want to, write a little bit, scuff up the diagram, that sort of a thing. If you're mistaken and the answer is actually 35 degrees, then hey, if you show your work, you can get part marks. And maybe you can't get 4 out of 4, but maybe you can get 3 out of 4. And that'll help your score out. Okay, so we're going to continue on. As I say, in the next video, we're going to do A2. So if you'd like to, feel free to join me there. And until then, have a wonderful day.